Hello, everyone. Good afternoon. I hope every one of you is doing very well. So now we go to chapter 5. Property of the new stochastic integral. And today we do section 5.1. Near martingale property. First, let me mention that in the Ito theory, so recall that in the Ito theory of stochastic integral or stochastic integration, they are two guiding property. The first one is a martingale property. And the second one is Markov property. And in order to have for these two properties, the important thing is this evaluation of the integrand. Is the depth endpoint. The depth endpoint of subintervals in forming the Riemann sum. Namely, here AB, and we have a partition T sub I minus 1 T sub I. And in the evaluation of an integrand, it is at the left endpoint. And as a result of this choice of the evaluation at the left endpoint, the resulting associated stochastic integral is a martingale. And also in the stochastic differential equation, the solution is a Markov process. Okay, so that is in the Ito theory. And let me remind you of the definition of a martingale. Note that a stochastic process xt for t between say A and B is a martingale is the definition of a martingale with respect to a filtration. If for any s less than or equal to t, we have the conditional expectation of xt given f sub s is x sub s almost surely. This is the definition of a martingale. Note that, of course, in order for this to make sense, we must assume that x sub t is integrable for each t. And note that in this equation, because x sub s is the conditional expectation of x sub t given f sub s. Therefore, x sub s is automatically measurable with respect to f sub s. And therefore, the stochastic process x sub t must be adapted with respect to this filtration. Okay, let's go to the next page. This is page 31. Now let's go to the simplest examples in the new theory of stochastic integration. Now consider the stochastic process. X sub t equal the integral from 0 to t, this t here, and b1 dbs. And we know that this integral for t between 0 and 1 is given by b1 times bt minus t. This is for t between 0 and 1. This stochastic process is obviously not adapted with respect to the filtration given by the Brownian motion bt. because you see here t is between 0 and 1, and here will be 1. Therefore, x sub t cannot be a martingale. It's not a martingale. This stochastic integral is actually the simplest stochastic integral in the new theory. And it gives us many ideas. So this xt is not a martingale, but nevertheless, let's compute the conditional expectation and see what happened. So here, observation. I'm going to find something new about this stochastic process. That S be less than or equal to t and between 0 and 1. This is 0, this is 1, and here we have S, we have t. And let's compute the conditional expectation of x t given f sub s. So let's compute this conditional expectation. Okay, this conditional expectation equals what? E conditional expectation of B1 bt minus t given f sub s. And now we write B1 bt as follows. B1 is B1 minus bt, and I put them together, plus bt minus bs, and I put them together. So here bt cancels out and bs, so I have to put plus bs. Oh, it should be like that. And times, similarly, bt, I write it as bt minus bs, group it together, and then plus bs. And then given f, I'm sorry, there's one more term. Minus t given f sub s. And that equals, and we have, the first factor has 3 terms, the second factor has 2 terms. And so now this times this, and then take the conditional expectation, because the independent increment of the Brownian motion, that is 0, plus this times this, bring bs out, and this is also 0. And now the second term, this times this is a square, so it's plus t minus s. And then this times this, again, bring bs because adopted, and it's 0. Okay, finally bs times this, bring bs out, and it's again 0. And then plus bs is bs squared, and finally minus t. And so that equals to t cancels out, bs squared minus s. So equal to that. Okay, this I stop here, and I'll continue in the next video.